Okay, in this video, we're going to use a model and diagram to explain Pythagorean's theorem. So the first thing is we're going to kind of talk about everything, kind of like what is Pythagorean's theorem. All right, first thing is we have to have a right triangle, okay? And so it has to be a right triangle, and it's noted here. You can see that the symbol there, that little box there means that it's a right triangle. That's a right angle, actually. And if it has a right angle, it's a right triangle. So we know that because of the scene there. All right, let's talk about some of the labeling here. All right. And so in this video, all right, so these are called legs. That's the sides here. So the right angle, the 90-degree angle box, it's touching both the legs. And these legs can be labeled A and B. All right. Now it doesn't matter which one's A and it doesn't matter which one's B. All right. Also, on a right triangle, then I'm just doing a little example. The third side, that's the one that's opposite of the 90-degree angle. See the 90-degree angle I'm covering here? What's opposite of that long is called the hypotenuse. All right, so this is actually, and you remember these are the legs. So the hypotenuse is always across from the 90-degree angle. So if you never know, let's say we have one like this and you don't know which one's C, you always know it's the one that's across. And we always label the hypotenuse C. So this is the hypotenuse. It's always the longest of the three sides. So if I have the numbers 5, 7, and 12, which one of these would probably be the hypotenuse? Well, it should be 12 because it's the longest of all three of them. Some people think that these two added up give you this right here, and that's not always true. In fact, most of the times, I mean, just rare that happens, and it just happens, it's just a fluke. So don't forget, the hypotenuse is always opposite. I've seen some where the legs that sometimes the leg looks like it's long, one of the legs, like some people think this leg is longer than this guy. And they'll label this C when it's not. Remember, here's my 90-degree angle, so, sorry. This is my degree angle, so I know diagonal is my hypotenuse, so I know this right here is C and not the other one. So this would be C, and these would be labeled A and B. All right. So now that we kind of talked about what is the leg and what's hypotenuse, remember, hypotenuse is always labeled. The hypotenuse is always labeled C. All right. So that's the hypotenuse, and this is the hypotenuse. All right. So we've talked about the triangles and the legs. So we know what the legs are. We should know what the hypotenuse is. We should know that C is always the longest of the three sides. All right, so I'm going to get rid of this right here, and we're actually going to model this. All right, so I'm going to actually show you the proof of a squared plus b squared equals c squared. And I'm going to put a little c in here. Oh, I did it again. I'm going to put a little c in there so that way we can kind of see it. All right, so that leg is the c, the length of the c. All right, so we are going to take A, and if you notice I got 1, 2, 3. It's supposed to be 4. It's just a little short. Let me fix that because so I'm going to fix this real quick. Ooh, I'm trying to make this better. Okay, let me redo this real quick. All right, so 1, 2, 3, 4. 1, 2, 3, and the fun part, of course. See if I can get this working here. The fun part, right there. All right. And we said we were going to label these A, B, and C. A, B, and C. All right, now let's check their actual measurements on a grid. And we're going to try to avoid this right here being other than that, and this too. Alright, so here we go. The A side looks like we have one. Oh my gosh. We have one, 2, 3, 4. So it looks like it's a length of 4. And so we're going to make a square on this side. So we're going to go 4 this way. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And my boxes is horrible. I'm trying to make it look a little bit nicer. Okay, so there it is. And if you think about it, we take, we're going to say A was 4, and A square is going to be 4 square, which is 16. So if you look inside this little box here, there should be 16 little boxes in here. And there is. There's 16 of those little guys in there. Alright, so now let's look at the B side. B side looks like I have 3 going across. So that means I'm going to have 3 going down. 1, 2, 3, 1, 2, 3, and I'm going to go up. And this makes 9 in there because 3 times 3 is 9. So we have that there. Alright, now we're going to calculate the C square. We're going to see about these two guys adding up to equal C square. Because Pythagoras' theorem is A square plus B square equals C square. Well, our A square is 16, our B square is 9, and now we're going to try to prove the C square, and I'll use a different color in this case. Alright, so this is how I'm going to do it. I got 3 here, so I'm going to go 4 over. 1, 2, 3, 4. And then I'm going to go up 3. 1, 2, 3. So I'm going to go. What I'm doing is I know this is 3, so I'm doing another right triangle. So I'm going to go 1, 2, 3, 4. Then up 3. 1, 2, 3. So I'll put my dot right there. Then I'm going to go up 1, 2, 3, over 4, 1, 2, 3, 4. So I'll put my little dot there. And then I'm going to connect my corners. And there we go. I've connected my corners there. Now, if I do my math right, which I'm going to separate this into little circles, and I'll do them in a lighter color so it kind of lighter color so we can see a little better. I'm going to connect my corners. So I'm going to connect. See how I made a triangle there? And then this one I'm going to go up here and make a triangle with this guy. And then I'm going to connect these two together and then these two together. So as I'm making more than one triangle, I'm making this one here, and then I'm making this one here, I'm making this one here, and I'm making this one here. Alright, now that I have my triangles all designed, if you notice I'm going to do the area of a triangle, and I want to change this, I want to move it here. I want to change the... Okay, so the area of a triangle is base times height divided by 2. Alright, so here is my base, and I probably shouldn't have used it as a color. There's my base, and it has 1, 2, 3. Then if I go the other way, 1, 2, 3, 4. And then I'm going to divide by 2. So 12 divided by 2 is 6. So this area is 6. Alright? Now if I did the others that way, I would get the same thing. 6, 6, and 6. And then I have 1 in the middle. Well, 6 times 4 is 24, plus 1 more is 25. Alright? So if I have C squared equals 25. Does 16 plus 9 equal 25? And it does. So you can see where a squared, that's right there, b squared, you add those together, you get your c squared. And we proved that mathematically just now right here.